Here are the answers for the day 2 bell work. Not all substances dissolve in water, but for the ones that do dissolve, the amount of solute that is able to dissolve in a given amount of water is called the solubility of the substance. If the solute is a gas, then Henry's law applies. Question A. The solubility of a gas is given to be this value at this pressure. What is the solubility of this gas if the pressure is increased to this new value? So this formula here is Henry's law. So you start by writing that down and then make substitutions. The first solubility mentioned is the 0.25 grams per liter. So that gets substituted for S1. The gas has that solubility at 96 kilopascals. That's P1. Then we're asked, what is the solubility? So S2 is our unknown. We leave the variable as S2. When the pressure is increased to 140 kilopascals, that gets filled in for the P2. This creates an equation whose only variable is S2. And then we solve this using algebra. It looks like we can multiply by 140 because that would get rid of the dividing 140 and get the S2 alone. So take the calculator, go 0.25, divide 96, and then times 140. And the result is 0.36 grams per liter. Question B. The solubility of a gas is this value at this pressure. What pressure is needed to increase the solubility to this value? So this is a question about solubility of a gas. So Henry's law applies. We'll start by writing the formula. S1 divided by P1 equals S2 divided by P2. And then make the substitutions. The first solubility is the 2.0 grams per liter. And the gas has that solubility when the pressure is 101.3 kilopascals. The next solubility is the 4.0 grams per liter. And the unknown is pressure number 2. We're asked what pressure. We have an equation in which the only variable is the P2, so we're going to use algebra to solve this. There are different ways to solve this. You could use cross multiplication because it's a proportion. You could flip both sides upside down so that the unknown is in the top, like we had in question A, and then we could use multiply to get it. Or we could even look for a pattern. For instance, I noticed that the numerator has been times by 2. 2.0 times 2 is 4.0. So that means the denominator will get times by 2. So I'm going to take my calculator and go 101.3 and multiply by 2. And the result is 202.6 kilopascals.